Thanks for coming to the last session of the day. It's a pleasure to be with all of you. And we are going to discuss an important topic, automate the automation, if I can say that, which is how we transition from automation to autonomous operations. We have a word in industrial manufacturing that is kind of siloed, complex in order to connect different things, and we all talking about how to modernize, and that's the topic that we are going to discuss today, how to get that manufacturing footprint, modernize, automate, and then go and move into autonomous operations. And I have a great set of panelists. So my name is Andre Marino. I lead the industrial automation business in North America for Schneider Electric, and I have here my fellow panelists, Andreas and Uli. So Andreas, why don't you introduce you before we go and start our conversation?
Thank you very much, Andre. My name is Andreas. I'm the CTO of Industrial Automation at Schneider Electric. My background is like 25, 26 years in manufacturing, starting with an SME and multinationals. So I've learned it from the beginning, basically what does it mean, bridge the shop floor from OT and IT, and I've seen the cycles over the years, which at the moment, it brings a lot of energy. What's possible now, what we can do with agents, what we can do together with powerful partners, and I'm really happy to be with you here in the last panel of the day.
Thank you, Andreas. Uli, what about you?
Well, I'm on the other side of the house, on the IT side, and I lead a function at Microsoft called customer-led innovation. Today I would say forward-deployed engineering, or whatever the term is these days. And the idea is to work with great partners like Schneider and our customers to figure out where this journey should go. And as Andreas already said, there's a couple of influences or confluences coming together, from connectivity to AI to automation, that I think will change manufacturing in dramatic ways. And it has to, simply because of some of the challenges we will chat about during our conversation. So looking forward to it.
Thank you. So I will probably, start asking if what I just said and what we hear in the corridors of the show about fragmented, silo, different platforms to manage, if that is a problem, why? So why we are in this situation and where we go from there?
Well, so think about the way the world has grown up. Manufacturing, especially factories and plants, were always something special on the side, isolated, let's call them kingdoms or queendoms, whatever it might be. And the IT teams always worked on the other side, supporting design, engineering, and then there was some kind of interchange where the data flowed into the factory at some point in time. But this was always a handover, but not really a fluid process, and it never was really a fluid process that went back either. So a round-trip information in terms of the factory learned what the product really could do in terms of how you manufacture it. That feedback loop, closing it, was always very hard. And now you start to see not only the silos in terms of OT, IT, design, engineering, those kind of things, but we're also starting to say that there is a world that we have to work with. And many companies have multiple factories where they have to start to say, how do I optimize across that entire factory estate? And not just looking at a single optimization, but more of the global optimization. And then you have the workforce challenge that I'm sure has been talked about a number of times here, where the aging population, and again, the Ford CEO, I think, said it best, he cannot hire people into his factories. And so we need to think through how we take the human capital that we have, take the most out of it by giving them the support and then connecting the dots. Mm-hmm. And I think that's really the way to think about it. Silos have grown up. That's the way it works. We need to figure out how to bring them together and then how to empower the people that we do have in those factories, in those environments, to do better, faster, cheaper.
Good. Andreas, I think that it's a very good explanation on how we see the world today and the reality of manufacturing, right? And we are talking about AI and the future of manufacturing, why fragmentation can prevent us to go there. So why is a problem for the autonomous operations being fragmented?
Yeah, so we have, you know, like when you're in a silo and you have not the data and not the access to the data, especially to real-time data, you can't optimize in the end the process and so on. So means this large also installed bases in brownfield, it gives some circumstances, especially when it comes to this large production sites and so on, to extract the data, to bring the data in check, to really apply a digital thread over the complete life cycle in the end. So that comes a little bit along with the vision we have with this open software-defined automation. So it's interoperability also of brownfield equipment and also of greenfield equipment working together, pulling up the data into platforms like Microsoft, addressing the whole life cycle and the whole digital thread of the future. And then we can optimize in a different way than before. So never seen before that we have now the opportunity on the platforms with the different agents we can create from different angles. You know, you can have an agent which makes an energy optimization on the process. You can have one which gives you like parameters when you have a different recipe on that. So it depends on the supply chain, what you have, when you have ingredients which are changing and so on. So you have all these optimization steps, and it also opens up that you go a little bit earlier in the definition phase, you get more in the specification. In the future.
Yeah, you mentioned open software defined automation, and that is a word that's super relevant, which is open. Correct? And open also connect, I guess, with an ecosystem of people working. Otherwise, you don't need it to be open, right? It implies that we are going together with partners and etc. So, and we've been working with Microsoft and customers and system integrators to develop that technology, moving towards to this world where you guys describe it, that we'll see less silos. If I understood well, a common data architecture that we can create those applications and use AI in a more, let's say, advanced at scale manner, right? So my question, Uli, to you, how you see that at Microsoft, and maybe I can follow up with when it's open, means we need to be taking care of cybersecurity as well, correct? Because then now what you're saying is that we are connecting those silos in a software layer, exposing the data, which is good for its purpose that we want to achieve, which is autonomous operations, but means now we are exposing industrial data, right? And I think we are all hearing reading the news of these new AI models even being shut down because national security concerns over cybersecurity. So it's a serious topic that's going on. So long question for you, how you see the collaboration in the ecosystem and the implications for cybersecurity industrial plants?
Look, playing chicken has never been a good strategy. Meaning trying to hide and effectively saying, no, we have no problem. By having a closed system doesn't work anymore because all systems are at the end of the day connected. And so for me, when you look at Mythos and OpenAI or Microsoft's M-Dash, they're all just capabilities where the AI is able to go and look at source code, but also binaries and find the vulnerabilities. And that's just an acceleration of something that's been happening since a long time. I remember the days I was at Microsoft when Blaster happened. Some of you might remember that, the Windows issues in terms of viruses and so forth. And Microsoft created then what's called the secure software development lifecycle. And I'm sure that Schneider is executing that very well. So openness does not mean that you are not secure. What that means is everybody who's participating needs to follow a certain set of guidance elements. One, have a secure software development lifecycle. If you have partners or you're doing software yourself, you have to really think about that. Defense in depth, minimal rights association, those kind of things. So very well-known practices that help your software to become safer. Then you have to think about a passive setup that says, what are your firewalls? What are your isolation techniques that are in place? Because a vulnerability might be okay if it's not exploitable. If you can't get to the vulnerability to exploit it, it's okay to have it. It's not great, but it's okay. And then the last piece is what I call active security, where you effectively have systems that understand patterns of data, and they look at the patterns and understand, oh, something's not right. They might know what's going on, they might not know what's going on, but they effectively will flag it. If they understand what's going on, they will have a playbook of what to do. If they don't understand what's going on, they will flag it to humans, and then you effectively can react to it. So the discovery of that something is going on is very important so that you can react to it. And again, this has not changed with these new AI models. It's just becoming faster. And just as a reminder, if you're in any industry, NIST v2, which is a guidance that's coming from the US, is saying that you have to be able to patch your systems, regardless what it is, in 48 hours, if it's a severity 0 vulnerability. So all of what I just talked about, meaning the patchability, software-defined, secure software-defined lifecycle, passive security systems, active security systems, is something that is a must-have in today's world, and these new systems just accelerate the need for it, simply because they are so good at understanding software. And especially the world is using open source software a lot, and that has it's the training ground for these models and technologies. So they know every piece of software that's out there. Therefore, being prepared, being ready is the key part.
Yeah, it sounds, at first a bit scary, right? Because you're entering a world that it looks like it's opening for vulnerabilities, but at the same time, it's contradictory because it's actually easier to protect a software-defined automation world versus a hardware and siloed world, right? Andreas, what is your take on that?
Yeah, so basically we are shifting from this hardware-centric world into this software-defined, full managed world, basically. And therefore we can deploy faster, we can react faster on the topics. So for sure, our systems at Schneider Electric, we prepare for CAA, we prepare for these topics. So it fits together with the view from Microsoft, from the software side, when it comes to cybersecurity. And so means IT, OT is coming really together. This is what we need also to speed up. This is also what we need to now apply the agent on these systems, especially when it comes also to control in the OT world.
Good. Well, sounds like interesting that we are moving to a world now that we can talk about autonomous operations, right? From just automate to now getting to a point where humans, they are not exactly clicking and commanding things. The computer and the AI will do most of the job, for sure, I think with some sort of oversight for humans. But how far we are from that reality, and probably if you can just explain what you guys mean by automate the automation.
So think about it this way. Software through agentic AI, is now capable of reading data, understanding your processes, your know-how, how you operate, and it will be able to take a look at this scenario in terms of what's happening, the data it's get fed. It will look at the know-how, and it will be able to develop a plan, meaning it reasons over the data, and then understands, here is what we should do. Because let's say a part got shifted. Andreas educated me on the importance of hazelnuts in the definition of certain chocolate products. If they're different from a different provider, it apparently changes whatever the oil content or whatever other aspects of the nut, which means the recipe changes and the production lines has to be reconfigured. That piece used to be a human thing. Now, with the right knowledge that's fed into the system, that it understands the impact of the changing supplier, it will go and understand, oh, this is a change. It will look at the recipe modules, understand what needs to happen, and reconfigure the production line automatically. And that's not future, and this is not fiction. This is what some customers are already doing. Obviously not at scale yet, but we're doing it in certain production lines for certain scenarios already. And that's something that was enabled through large language models, specifically last year when the language model started to learn how to reason. And that sounds very human. It's a very human-like process, but differently implemented, obviously. But that's a key part where the system can actually look at it, the scenario, look at its know-how, and reason over both parts, and then come to a conclusion of how to go forward with a plan to execution.
Understood. Andreas, I want to see your take.
Yeah, you know, when you look at automate the automation, let's look a little bit from a practical OT view on that topic. So the hazelnuts obviously is a chocolate bar.
Why the hazelnuts? You have something with chocolate? Or
no, I
just
like the chocolate bars and so on. So
I
like,
thought you
know,
being
like
German, you like beer, but...
and chocolate.
Okay, good.
And chocolate bars. You know, it's a recipe management thing. So you can go in food and beverage and so on. And there are some the recipe and also the supply chain is important, you know, in these days. And so you have to change that in the process. But I want to go a little bit back in the process of developing such food. You start today when you ask something with your smartphone, or when you search something, you start with a prompt nowadays. So it also has some influence how you design in the future, like food. So you start with a chocolate bar and say, okay, look, I want to create a chocolate bar maybe for this and this market. Can you give me from that prompt the specification, and from the specification what I need for production equipment in the end, and also when we have open software defined applied down to the function block in the PLC. And we prototype that with the ecosystem of Microsoft behind, with all the cybersecurity and all the ingredients you need. And so it is possible in multi-agent systems today to do that. So the human, basically, the agents ask the human a kind of recommendations. You say, I want to go this way or that way and so on, but it flips a little bit how you design this, how you interact with the different departments also. And it brings you flexibility, it brings you better time to market in the end, and it brings you also the option that you can do exactly when you produce in this whole life cycle all these fancy control loops and say, okay, I learn in this control loop of the production, my KPIs are energy savings, more productivity because I can adjust the nuts, I can adjust the ingredients, I can do it faster, I can adapt on that. And then you go over and have this on the complete life cycle view and optimize the system. So it's a complete new view on this life cycle, and it opens up a complete new view on automation. And the beautiful thing is, it's here. It's not future talk, it's here. So the question is now how we can deploy it at scale. And so we have the ingredients. Open software defined is very important because we have still the brownfield. We have still connect a lot of different factory components. This is something we cannot neglect. On the other side, we have to educate the workforce that it starts with a prompt, that it's complete new user interface into the machines, into the process itself, into the life cycle. So all is here. This is the challenge, but this gives tremendous efficiency gains for the complete life cycle.
Yeah, and I you know, it sounds like futuristic, but I welcome you guys to go to the Schneider booth, and you can see 7 agents starting a complete plant from a spec that you load, and then you see up to the end of the digital twin being built, which is quite impressive using software-defined automation. And you know, we can, like you rightly said, I think the question is probably not if that's real or not anymore. The question is what are the next steps and how can we scale that, right? Because I think we have an audience that some are like close to that and getting close to that, but someone in the audience maybe still with fragmented operations. And so what's the recommendation here if I was like running a plant in a brownfield and I still have all my siloed systems, where we start from?
So the first thing that I think we all need to start thinking about is how do you connect your assets? So start at the asset base, connect them inside the factory. There's lots of ways of doing that. Again, the open software defined automation has a very clear pattern of how to do that. Again, in the example that Andreas and I designed and built, we used effectively the Schneider automation capabilities, and then we used Microsoft's IoT operations capabilities to connect all the capabilities and then bring the data into a consumable place so that we can start to learn what's going on, and then build the loop so that we can deploy changes into the factory itself. Obviously under lots of control so that there is no, surprises for this factory in terms of some change coming in. No, these are all very well managed, very well staged so that the factory stays in control of how changes get applied and deployed. But at the end of the day, you start with connecting the asset, you start with connecting the factory, you start with collecting data, understanding what's going on, and then determining the actions, be that agentic agents or be that coding agents, whatever it might be, that ultimately close the loop so that you can really drive the end-to-end part. So that's the factory side. But then the other half that Andreas kind of sketched was from the design of the food all the way into the supply chain world, all the way into the production world. And again, that's another set of connection points that we need to make both technically, but also logically, meaning how does the prompt for the chocolate bar get passed over to the logistics people so that they can buy the right hazelnuts or source the right hazelnuts, and if they have different sourcing, how do you make sure that the characteristics of the elements are being fed back into the recipe management and then ultimately into the production line? And that whole connectivity is not technical in terms of sending 5G lines or something. This is really semantic modeling that has to go from one stage to the next, and that process know-how is something that Schneider has very well implemented and understood. And then obviously partners and customers are out there that have their own perspective that can then be layered on top of the tools that both Schneider as well as Microsoft provide in order to go and really optimize that flow from not just a generic chocolate bar, but to your chocolate bar. And I think that's the key part that has to happen in order to make this work.
Okay. Andreas, we definitely need a lot of technology, but I think frequently, we get asked, should we start from the technology or should we start from the problem we want to solve first?
So like I said,
what do we do?
the technology is here. The technology is here. So we start from the problem. We have now the technology in our hand to come in with a prompt on a large language model and start really with the problem. And to add on Uli, it is not only a Microsoft and Schneider thing.
No.
The agents work in an ecosystem, and you can think of, you have the chocolate bar, so you have people, they are food designers, so there are agents for food design. You can have agents for mechanical design, which brings you in the end the mechanical design for the packaging in the end. You have the Schneider agent, which gives you the function blocks on our EAE software package for the PLCs, for the equipment you need. So basically, you can also have like startups coming in with their view, providing an agent to the system. So it's really a new world how agents can work together in a secure environment and do the job. And therefore, you shift basically to the customer need. And like I said, the bet is faster time to market, and you can faster adjust if the supply chain is disrupted or other topics on the recipes on your manufacturing equipment.
So let me push a little bit on this one. So I completely agree with leading by the business side. But if you don't have a vision, you can do as many business understandings as you want, because you will end up always at the same of what you're already doing. So from my perspective, the vision, the technology, and the business problem have to come together in order to really solve that. And that's really what we showed at HMI
Yes.
together, of how vision and business scenario come together, and then the technology implements both parts, the vision part as well as the business scenario. And I think that's the important part, at least from my side. If you don't know where you're going, you will not get anywhere.
You
Yeah.
know where I am. Exactly.
Yeah. Well, it's fascinating, right? Because a year ago at Automate, we were just discussing about, what is AI and where this is going. And just in a year, I would say, we are already talking about prompting, say, I want to produce a chocolate bar, and having agents building your factory from a spec just in a year. So it's exciting, but sometimes it's overwhelming, right? And I just welcome all of you not to get overwhelmed by the technology. Don't get scared, because ultimately it's a people change. And I learned that from my boss, which I think is a very good way to describe technology cycles, right? In the beginning it's crazy, then becomes dangerous and becomes obvious, right? When I was young, my mother said, never talk to strangers online. Never get into a car with a person that you don't know. Now we do Uber, Airbnb, and it's obvious. And I think that will happen eventually with all this technology manufacturing as well. So I want to close that, because you guys, you discuss about chocolate, and we had beers in between. I know we have food, and we get to the end. So it was a pleasure to have this session with you. I think we closed from yesterday talking about the state of the automation, and we discussed during the day of many different things, and we are closing the second day about autonomous operations, which is kind of a significant speed in just 2 days of discussion. So it's a lot to consume. So 30 seconds for you, Uli. What's coming next?
What's coming next? And again, all of that is already here. Agents talking to each other, working with each other, and discovering each other. And also building bridges automatically where the bridges don't exist. So that means once you have the capability exposed, let's say your assets in an automation fashion, and accessible for agents, the agents will actually make the connections of how the production line assets actually work together. And sometimes you don't want that, you want it deterministic, so that you can say 1, 2, 3. Sometimes you do want it simply because the agents actually know more about what's going on, because they see the real-time data feed and they can process it. I always smile a little bit when I see these HMI interfaces on assets. There's a lot of data that asset produces that is never being shown, because the human would never be able to consume it. Yeah. But now an AI agent can consume it and can draw the right conclusions, what's going on with that asset or with the process that's happening on that asset. And then effectively lift up the, conclusions to the human, so that the human gets to see not the raw information, but intelligence that's based on what's going on. And if I can effectively say, is it a human or is it another agent I surface it to? Those are some of the changes that we are seeing already in software design and some other things, and it will happen for manufacturing as well.
Okay. Well, we are very close to the end. Andreas, 30 seconds to close the panel.
So, like I said, the future is here. We showcased it. Powerful partner ecosystem. For me, the next frontier is basically over the life cycle, bring this digital thread together. It changes the behavior, how we address OT, how we produce in the end, how we start to think of, basically to create goods in the end, So it starts now with a prompt. It starts now to create a specification out of this, and then it's an interaction between the machine, agentic, the agents, and the human. And this we have to figure out, because it changes completely what we can do and how we lift, in the end also the productivity again. And this is all about, it's performance, it's productivity, it's energy savings, it's the next frontier for manufacturing, it's here.
Okay, well, super interesting. I want to thank you all. Yeah, we have, let's say, time for a question, then we go. And I can repeat the question, you tell me. Okay. So the question is how far we are from going from intent to production. Whatever is the, yeah. I can take that maybe, and then you guys can
Why don't you go for it?
Yeah. So I think we are not very far from it. We are far maybe to have scale, right? So far, I mean, in today's time, you see the evolution in 1 year we had, right? I welcome you to go to the Schneider booth and see a real application where we just do more or less what Andreas described, not from a prompt like I want to create a chocolate bar, but from having a spec of manufacturing that I want to build and see the agents actually building it, creating every single component, creating the devices and all the programming, right? So we are getting close to that. I'm not sure will be like 6 months that we are seeing entire factories being built out of, I want to build I want to create a chocolate bar. That's probably like some years from now. But if you think about how fast things are going in the technology that we already have, we're probably not far from imagining these things that are going to come to us soon, okay? So again, I think if you go to our booth, then you can see that for real. So you probably is a better way to you can feel that, right? Instead of me just saying that we are close to that, okay? I want to close the panel. I want to be respectful. Uli, I know you need to get Uber and go to the airport. There's like some food there. You made us a bit hungry because of your chocolate story. So thank you again. It was a pleasure to have this session with you. Thank you.
Thank you.
Thank you very much.
Thanks everyone for being here. Thanks to Schneider and the panel for excellent conversation and those wonderful refreshments as well. So hope you can grab some on the way out. Thanks so much for being here.